Hello, my name is Grayson Wong, and welcome to the Plano Green Team oral presentation. In this video, we'll highlight our team's mechanical, electrical, and communities progress. We're an independent team not tied to any school or school district, and our team members have come from all parts of the city to work on this amazing project. Without further ado, let's introduce the team. I am the team captain of the Plano Green Team, and here are the 9 engineering-driven members of the team. And now, let's head on to the mechanical group to see our car come to life, starting with me. I'm also the lead mechanical engineer for the team. First, we use computer-aided design software to model the frame, shell, and other components. We provide a chronological pictorial representation of the designs we created and tested from inception to final prototype by prioritizing structural integrity, safety, and ease to build. And obviously, the designs are always changing, so in some of the visuals, you'll see recent versions of the vehicle, but the last image depicts the current design of the car. The frame resembles a relatively simple design with mainly 90-degree angles and a surrounding crush zone built into the car. We believe it to be simple enough for a new team to build, but elegant enough to reach high performance. Second, I utilize computational fluid dynamics software to optimize the aerodynamics. This consisted of me analyzing different shapes of the car and the effect it has on air resistance. Also, I was able to minimize the frontal static pressure of the vehicle through the design and analysis of various nose cone shapes. I also have designed many other ancillary components of the car, including the canopy. Overall, from 2 years ago when I was a complete beginner and to the solar car world, to now, I can't even put into words how much I learned. After a long process of designing, testing, and revising, this is the current design. And with that, we look forward to seeing our hard work come to life at the Texas Motor Speedway this summer.
Hello, my name is Donovan Douglas, and I am in charge of the car body and parts for it. After Grayson designed the car shell, I was tasked with creating a 2/5 model of the car shell in order to visualize the shape and scale of the car and practice the shell construction beforehand to optimize the process when we build it for our actual car to race. Later, I was tasked with creating an outline and a full-scale model of the canopy. This was done mainly to see how much space the driver would have when they were sitting inside of the frame and the canopy at the same time, and also a visual aid to see how big the canopy was compared to the car.
Hello, my name is Matthew Devaling, and today I'll be talking to you about our front suspension. The front suspension's main advantage is that it reduces the amount of space between the steering axis and the tire patch, keeping it constant throughout travel. Additionally, it gives space for the driver's feet, and it's quite modular, and it eliminates the unnecessary complexity in double wishbone designs. By moving the left and right shock collars, you can adjust how bumpy or smooth the ride is. Additionally, I helped Grayson by cutting the roll bar to size to better fit the canopy and the roll cage.
Hello, my name is Paulien Lopez, and I just recently joined the Plano Green Team. I was able to isolate the reclining function of this donated electric wheelchair and create a reclining seat to be used in the car.
So now we'll move on to our electrical team. Hi, I'm Iris, I'm Untitled Electrical. If you look at our first visual, you'll actually see that we use Tinkercad to design and simulate our aux system, mainly because it's quick and efficient, as well as our main controller is run by Arduino. And if you move on to visual number 2, you'll notice that over time iterations, we added relays in order to control an external power source to power our auxiliary system, because the Arduino itself only gives us 5 volts, which is not enough to power our whole auxiliary system. And then if you move on, we'll see that we added even more. We added stuff such as our horn, buttons, and lights. If you move on to visual 3, you'll see that we added our low voltage alarm, which is a big deal because it was really interesting designing this. Using our analog pin off Arduino, we were able to measure the voltage which was needed to set off the alarm. And then you can also are now able to measure current, which will be useful for the driver during the race, by using our analog pin as well as a known value from a resistor to find what our current is. And then if you look at our fourth visual, you'll see that we learned Eagle in order to create a clean professional schematic of our design. And you'll see side by side of each other, you'll see our original Tinkercad, our hand-drawn schematic, and then our Eagle schematic. And then finally, you'll see we have actually built this all out physically on this giant piece of wood, which is as a proof of concept of what we're actually going to be applying to the car, and it actually works.
Hello, my name is Zaki Namdar, and although I've been on the community team focusing on making videos like this oral presentation, recently I've been on the electric team helping to make the main electric system. My biggest engineering decision so far has been how to arrange the solar panels. Our team was donated 10 solar panels, and after testing multiple configurations, I decided that I will have 5 strings with 2 panels in each, which meant that I was prioritizing the case that our car ran into shade, which would allow as many panels to still function because most were connected in parallel, while still keeping the voltage in each string constant, which would allow the MPPT to function at full efficiency.
Hello, my name is Raghav Donovan, and I am part of electrical for the Plano Green Team. I worked on the main schematic for the solar car.
With our main system, we used Eagle to plan out our schematic and went through a variety of difficulties and made changes to our design. The biggest design change we made was the implementation of the motor relay. We decided to use the motor relay as it will be a requirement next year, and we would prefer if we didn't have to go back to the drawing board next year.
And of course, none of this would be possible without the help of our amazing sponsors, so we'd like to take a second to acknowledge them and all the support that they've given us. First of all, we have Spirit Communications, and they are generously a gold sponsor. We also have John Kraft with State Farm as a silver sponsor, and the East Plano Islamic Center as another silver sponsor. We'd also like to thank Polymer Shapes for donating materials, and we'd like to extend a special thanks to Matt Sant for all of the help and guidance that he's given us. We're so grateful to all of these people for all of the help and support that they've given us throughout this process.
Another project for the community that we've been working on is providing free engineering courses for elementary school students. In these classes, we go over the basics of engineering and hopefully inspire some future STEM students. We've partnered up with local nonprofit organizations such as Outlook Tutoring, as well as local libraries and recreation centers right here in Plano, Texas, to help set up these virtual classes. In addition to this, our community team has worked very diligently on our team scrapbook. In addition to the basics of engineering, our lessons included hands-on activities regarding the evolution of cars, paper airplane building, and even a short Tinkercad tutorial.
Well, we just walked you through some of our design decisions and projects we've been focusing on. We're all so excited to be working on this car as a part of the Solar Car Challenge and race our final solar car at the Texas Motor Speedway this summer. And finally, happy racing to all the teams.